Hi. In chemistry, we do a lot of math, and in beginning chemistry classes, the biggest sort of math trick technique, whatever, is what we call dimensional analysis or unit conversions. Some of us, myself especially, really push a front-end part of that I'll refer to as a roadmap, and hopefully that's somewhat familiar to you. Sometimes we do have to use true algebra, systems of equations, whatever, but generally we really don't even have to go that far. The algebra we use is just rearranging a fairly standard equation. We see that a lot in, say, the gas laws, where the equation is pressure times volume equals moles times R times T, etc. So what I want to do for a couple of minutes is just do a problem, but use both the RoadMap technique and separately do the algebra technique, and just sort of show that they really are the same thing. So the question that we have here is, we're given that aluminum has a density of 2.7 grams per cubic centimeter. Density is a subject in Chapter 3, probably familiar to you already, but again, the problems about density tend to be more in Chapter 3, I think. So our question is, what's the volume of 15 grams of aluminum? So in the world of roadmaps, we'd say, oh, well, we are going from, the starting thing here is my grams, and we are trying to find volume. Now, it doesn't say what the units on volume are, but we'll just sort of assume we're going for cubic centimeters there. So our roadmap is a simple one-step thing where we're going to go from grams of aluminum to cubic centimeters of aluminum. Alright, and so to actually do that, my solution here is that I've got 15 grams of aluminum. I can look on my sheet and I have a conversion factor of 2.7 grams is 1 cubic centimeter. So that tells me, or this rather tells me, I'm starting with grams of aluminum here, so in my denominator I want to have grams. And so I'll have 2.7 grams of aluminum in my denominator, and that is 1 cubic centimeter. Now note in this I put a 1 on the top, whereas in the conversion factor it's just sort of implied. We don't bother to write the 1 there because that's a normalized ratio. But it's nice to show that I haven't forgotten anything here. And so when I do this, again, sort of my my solution here, my unit conversion stuff here, I have converted grams of aluminums to cubic centimeters of aluminum. So we could throw that back in there too. And so the only thing left is cubic centimeters. I pull out the calculator. 15 divided by 2.7 gives me 5.56 centimeters cubed. Okay, so again, this roadmap thing really works for almost any calculation that we have in chemistry, but sometimes there might be an easier way or a more familiar way. And in this case, there is. We have a general equation, and that general equation is basically a definition of what density is. And so we might say density equals m over v, where m is understood to be mass and volume is understood to be, or v rather, is understood to be volume. This is true whatever units we're using. We could say the density of water is however many pounds per gallon. It could be grams per cubic feet, etc., etc. But if we're consistent with this problem, we'll have the density in grams per cubic centimeter, the mass in grams, and the volume in cubic centimeters. Okay, the question here, sort of a different approach, is, well, what are we trying to find out? We're trying to find the volume. And so what I would want to do is I would want to rearrange this and solve for volume. So here's my algebra. I'm going to say V equals, and if we have to do this in 2 steps, multiply both sides by V, divide both sides by D, and see what happens, we can do that. By inspection, we recognize that I can do exactly that again, sort of just by looking at it, that might work in this case. But again, what I'm doing here is I'm multiplying both sides by v, and I'm dividing both sides by d, and so I end up with v equals m over d. Okay, so however I get there, I want to get that. And a nice thing here when we're dealing with more sciencey things than just straight arithmetic, we'll have the units at the end of the day show us that we did it right or not. Okay, so at this point I've got volume is mass over d. That's coming from the general equation that we know. We might even call that a definition. And then I just plug in the values. So my volume, or value rather, for mass is 15 grams. My value for density is 2.7, this guy, grams per centimeter cubed. And when I do the calculation here, 15 divided by 2.7, look at that, I get 5.56. And when I go through and look at the units, I'm going to cancel my grams. And now I have 1 over cubic centimeters, which gives me cubic centimeters. And I have to be really careful with this, inversey stuff, but it works. Okay, so again, we expect to get the same answer. We do. It's a relatively simple example, but what I would like to have as a take-home lesson, if lesson's the right word, is that there isn't just one way to do a lot of problems. The RoadMap stuff is good for very general solutions to word problems. A lot of the stuff you see in Chapter 2, when we get into real chemistry of chemical reactions where we don't have a general equation, RoadMaps and this generic solution stuff is really the way to go and be solid at. And this really, this is the skill we want to get out of the first couple of weeks of the class. But like I say, sometimes 6 and 1/2 dozen the other, we might do more of this general equation approach. Sometimes we really have to because the problems tend to be a little more difficult to set up with a RoadMap approach. It's doable, but it tends to be a little sloppy. So kind of in summary, just start a little table down here. Things that I would do RoadMaps with are going to be general word problems, unless they're a really specific case, chemical reactions. If you want to look forward, there's something called limiting reactants. And then I'll just say etc. There's lots of things we do here. So a very general thing, we want to be good at RoadMaps. But there's times that the general equation, quote-unquote, algebra approach is almost essential. We certainly want to have those skills. And those would be things like gas laws. And this is going to be Chapter 8. There's a couple of gas laws. PV equals nRT is one of them. And it's an nRT. And the issue here is that you have 1, 2, 3, 4, 5 terms. And we typically want to solve for one of them. So if we wanted to solve for P, it would be that P equals nRT over V. If we wanted to solve for R, we'd have that R is equal to PV over NT, etc. There's another gas law. It's even more complicated looking, but P1V1 over T1 equals P2V2 over T2. And same deal, we typically want to solve for one of these things. So we're gonna have to do a little algebra for those, but it's not hard. We're not solving quadratic equations, stuff like that generally. And the other place that we need to be able to do this has to do with equilibrium, which is Chapter 10. And in Chapter 10, without getting too far into it, we come up with these equations where we might have that some constant is equal to some compound concentration, and never mind the notation, let's just say squared over something else to the first power, and we might have to solve for, say, that one of the terms there. And so we'd have to do whatever algebra is necessary to rearrange that. And again, we'll get there when we get there, but these types of things tend to be more easily approached with an algebraic attack, though not impossible to do with road maps. Whereas a lot of what I'll call ad hoc problems, you're just thrown a bunch of information and we have to do whatever we have to do to solve it. Those lend themselves to this roadmap strategy, which is really turning the words in the problem into the start of a arithmetic expression, and then we go through and do the calculations. All right, I hope that doesn't make things muddier than they might have already been. Math is your friend. Just be disciplined as you do whatever manipulations and calculations you need to. All right, enjoy the day.